Well, hey everyone, really excited to go through this session. One of the big things that we generally see when we're working with customers is we've got a ton of agents, we've got thousands and thousands of different endpoints. How do we go and manage these? How do we go collect data from those? How do we make sure that what we've done is in fact what is required from the organization? And if we do need to make changes, how do we go enact those quickly, efficiently, and making sure that those take place? So with those things in mind, we've built a lot of this fleet management capability, which we're going to walk through here. And what I'll go ahead and do, let's start with a few level set slides here. Awesome. So one, we're going to just talk a little bit about Calyptia Core, what it is, how does it work, and its relation into a fleet, and then really just cover what a fleet is, right? We're many times this vocabulary gets thrown around and we have no idea what it represents in reality. So we're going to take a step back, talk a little bit about some of the data structure aspects about a fleet. We'll talk about some use cases, what we've seen within large organizations, thousands of servers, and then finally talk a little bit about two very specific use cases and how those work with some fairly deep demos. So first, let's talk a little bit about kind of the complex data infrastructure that exists, right? When we think about Calyptia Core, we're an organization based around two really great open source projects, FluentD, FluentBit. And what we've seen as folks have gone and started to implement a ton of infrastructure is there is this extraordinarily high amount of complexity. There's 4 or 5 different agents, there's different endpoints, different sources. And this doesn't necessarily seem like a problem that is going to reduce itself over the course, right? There's a new database coming out every day. There's a new source that's getting added. And effectively, as a observability or security organization, we are being tasked with how do we make sure that there's no blind spots? How do we ensure that our operational efficiency is very, very high? And similarly, from a security side, if we have a new SaaS that we take on, how do we make sure that we don't have any blind spots with that? So really, where we've focused in Calyptia's side is by allowing you to look at that data generation, collect it as close to that where that data generated as possible, but start to perform some complex logic, some processing, some high value functionality on top of that. Lastly, then routing it to wherever it needs to go. So whether that is Elasticsearch, whether that is OpenSearch, whether that is Amazon S3 for archival or a SIM, having that capability and ease of use to go and do that. Now, if we talk a little bit about what we've seen in a lot of large infrastructures is you might have this amount of collection from different sources. You might have a bunch of connectors. One thing we've seen over the past year, which has been fun, is a ton of ArcSight migrations. So whether we've seen it within very large telcos, we've seen it within very large organizations, seen it within government, and typically there's 4 or 5 different ways of going and collecting that data. Then, of course, as folks decide on what end platform they want to use, leveraging things like something like Calyptia Core. So number one, how can I go onboard new users very, very quickly, make sure there's an ease of use, self-service for onboarding new data sources. 2, do the processing and removal of noisy or non-influential data. And then last but not least, routing that to wherever it needs to go. So if the organization is migrating to something like a Dynatrace, how do they do that with efficiency and speed? Now, if we think about the architecture of Calyptia Core, this is going to be really important to how we think of fleet management and how do we think of how this is going to be implemented within your organization. The first concept is this idea of a control plane, and the control plane being the place where, one, you're accessing the user console, you might have authentication in there, might be logging in. It's something that's serviced as an account. It gives you that ease of use for creating pipelines or managing a fleet, and of course, the control service. Now, the control service is where this data pipeline or data plane, excuse me, is going in and talking to the control plane. And then you'll see there's another square here around meta observability. Now, within fleets and within Calyptia Core, we are automatically capturing a lot of metrics about how things are operating. Why do we do that? So you're able to make more informed decisions, make sure that things are flowing as intended, and really understand holistically how a fleet might be operating or how a fleet is sending data. And of course, from the data plane side, what you'll see here is that is something that lives on your infrastructure. So whether you're using a private data center, whether you're using a public cloud, making sure that data plane lives as close to the data as possible, such that you're processing things close to where they are emanating from. But also from a security side, you're not firing data all the way up to a cloud to process it to only fire it back down into potentially some of your self-managed or on-premises type of backends. So within this context, right, you will have your scalable pipelines, your Kubernetes pipelines, and edge and agent pipelines. And within fleet management, today, what we'll specifically cover is how do edge agent pipelines work, as well as Kubernetes pipelines. So with that, let's talk a little bit about what is a fleet. All right. Many times, again, as I said, this vocabulary gets thrown around, and sometimes one vendor might define it like XYZ. And here it's really important to cover what does a fleet represent. And a fleet is really a grouping of FluentBit or core agent instances. So it can be as simple as a single agent that is subscribed to a fleet, or it can have an N number of agents. So why do they share this configuration? Is because they share a common purpose, a common mission, if you will. So some agents might be collecting data from, say, your Windows servers and routing data to Amazon S3. And this is part of potentially a security team, or this is part of the compliance and audit team. And if the compliance and audit team is instructed to capture an additional log source, or is instructed to send data to a different destination or an additional destination, then effectively that comes downstream to all of the fleets within that group's purview. So whether that is a purpose that needs to be updated for, hey, we need to now collect this log file, we need to go route data to this new backend, configuration and purpose is a fleet. Now, that's not to say that a single team might only have one single fleet. We might have 50, right? We might have one for Windows that are running on Active Directory servers. We might have a fleet that's for Ubuntu servers with Apache server on top. We might have some for Java, some Go, all sorts of different applications might require different fleets. And the nice thing, as we'll show in the demo, is you have that flexibility to go define and build many of these fleets together. Now, the other side of a fleet is, as they are shared in configuration and purpose, they allow, they're also scoped in this sense of I'm collecting data, I'm routing data, so they collect metrics about themselves. So a fleet also represents a collection of metrics across many different endpoints, servers, or agents. Right? How many files did I read? How much data did I send? This is another encapsulation of a fleet. And if I was to add one more thing here, right, where does the term fleet even come from? Generally within shipping, when we're thinking of packages or logistics, right, a fleet might represent all of the UPS or FedEx trucks that are going across, picking up packages, shipping packages, dropping off packages. And so they have a kind of shared configuration or shared purpose of collecting and dropping off packages. So again, this is where fleet. Now, why fleet, right? What are the use cases that I would want to go and derive fleet? This is something that we very commonly hear is my organization is leveraging tools that allow us to do configuration management at scale. That might be something like Ansible, that might be something like Puppet, that might be something like Chef. And really, if the organization is really locked into those configuration tools, that's great. We can plug into those. You can leverage a lot of stuff around configuring agents with those configuration tools. Really, this is a purpose-built way to go and configure, understand an agent with, again, those niceties around the metrics and the monitoring for an agent. So this is what we've heard from our users is, yes, the organization has a Puppet, Chef, or Ansible, but learning something brand new versus something very domain specific can have its trade-offs. And the use cases for this fleet that come about, the first one is really how agents are reporting, right? If I have 50, if I have 100, are they correct? Or do they have the configuration that I've set? And also how much data is flowing, right? If I'm collecting a file across every single server, and the group is reporting 1,000 TB, I don't know, a petabyte of data, and I see one agent is collecting way more than the others, I can potentially distinguish that something might be going wrong there, or really use that to trace and say, hey, my build just exploded on the back end. What might be happening here? Now, when those things happen, we need to be able to react effectively, quickly, potentially even in an automated sense, right? We may want to have the fleet update if a particular threshold gets triggered, or if a particular incident comes about, or a policy gets enacted. So updating a large amount of servers, this becomes another place where within a fleet management use case, we can say, for the specific fleet of XYZ servers, let's go collect these logs, let's go collect these metrics, these traces, make sure that we're adhering to the policy of the organization. Now, the last one, which I think is really fun, is around schedules and changes. So while fleet management is typically seen as a very slow process, we have in many of the old OSs, Patch Tuesday comes along. That's when the upgrades can hit. Before Patch Tuesday, after Patch Tuesday, we've got to wait or hold off on a change. Now, with fleet management being something that is extremely fast to go take place, which we'll show here in a bit, this gives us the ability to go say, hey, on these changes, we might want to have more logic built in. What does that mean? On the weekends, for example, if we're collecting a ton of traffic, ton of logs, which naturally might be going down, or even metrics, we might say, hey, instead of collecting on a 5-second interval for all of these metrics, let's collect at a 5-minute, right? Things just tend to not go too wrong during the weekend. So we have this ability, let's go schedule that in. On the alternative side, if something is going wrong, fleet management gives you that capability to say, we want to collect at a much, much faster cadence. We want to collect these logs that typically we don't. Potentially you've been excluding debug logs, and now you want to include those within your collection rules, just for the sake of doing some fast debugging, fast troubleshooting. So one of the nice things here of fleet management, in particular fleet management with Calyptia, is that it starts to give you more opportunities to leverage speed to meet some of these use cases that traditionally you potentially don't have anything to go solve with. And let's talk a little bit about very specific use cases. So things like Kubernetes fleet management. Now, when we think of different ways that you can go deploy, or you might be running your enterprise, really it comes down to a couple of different assets. You might have your laptops, your Mac laptop, your Windows laptop, maybe you're running a Linux laptop as well. And those clients just need to collect some data about the client machine, how it's running, how it's operating. And you want to see, is that client up? Collect some security audit events, and then route that to the particular backend of choice. Now, the second thing is, if from that asset, from the client all the way to now I have servers, and servers might be generating way more specific things that are important for the organization. They might be important for the application side. And we want to be able to collect those logs at a much, much higher pace or higher scale, and of course, not impact any of the other applications that are running on the server. Now, the next side of that is without even the server, maybe we have containerized environments. We have Kubernetes, we have these orchestrated environments, and the collection mechanisms that exist within those orchestrated environments are far different than what would typically be seen with the client or a potential server. The reason is there are different segmentations, ways to go slice and dice that data. For example, we might have things like Kubernetes events, Kubernetes metrics, namespace logs, and we'll show a little bit of how all of that works here in the demo. So with that, let me go ahead and I'll switch over to my Calyptia Core UI. And here I have one of the core instances here that's running and deployed actually on top of a very small cluster, single node cluster of Kubernetes. And for those who are, potentially not familiar with Kubernetes, we might have different teams that operate out of different namespaces or different segments, right? So a cluster might be shared for an organization. You might have one team that's security, one team that's applications, one team that's for the system. And each of these teams might have different inputs, outputs, processing that is required for them. And typically what we see when an organization goes and adopts Kubernetes and starts to do some system monitoring is that they deploy Helm charts, and then they're constantly modifying some configuration, trying to match the Fluent configuration with the Kubernetes configuration. And that can get very tedious. It can get quite overwhelming. And so with what we've built with Calyptia Core on the Kubernetes side is really a purpose-built and first-party view for how this works. And so what I'm showing here is instead of a typical source, which may be syslog, it may be an agent-based source or collection from audit logs, I actually have here all Kubernetes logs. And from that, I'm sending it to two destinations. I'm sending it to Red Panda, which is like a Kafka type application, and then I'm sending it to a null output just as an alternative destination. Now, if I go ahead and open up this window here, and I do kubectl, let's increase the size here so it's easier to read. If I do kubectl get pods, I can see I have a couple of applications running in my Kubernetes clusters, and I can do kubectl get namespace. So here you can see I have a couple of namespaces. I have some that just come by default within Kubernetes. I have a security, I have an application, I even have a fleet namespace here. Now we can, if we go back to the UI here, we can go look at this source and you'll see all of those namespaces, right? 7 namespaces available. I'll go create a new one for the purposes of this demo. And what we'll try to emulate is within a shared cluster, we're going to create a brand new namespace, deploy an application. And once we deploy that application, we want to route those logs very specifically to a particular end destination. So first, let's go create a new namespace. So we'll call it demo namespace. Perfect. That's gone and been created. And if I come back here, let's just make sure it's now populated within the UI. I'm going to go do a refresh. So it's loading the Kubernetes environment again, making sure that any of the events, let's go click source again, and perfect, right? Here is that demo namespace we just created. We went from 7 to 8. So let's go ahead now back into our cluster UI. And what I'll do from here is we're going to run an application very specifically in that namespace. So we're going to run Nginx. And we're going to make sure that this is in the demo application. And you're going to have to excuse me because I am doing all this live. I forgot the actual commands to run a pod like this. Okay, cool. That ended up working much better than I anticipated. So let's go ahead and kubectl get pods for the namespace demo. And there's an nginx in there. If we go do a logs on top of that, looks like it's generating a few logs here and there. So what we're going to do is say, let's go grab all of the logs from this particular pod, and let's route that to something fun like Red Panda here. So we'll go back over here, and we'll add a new source. We'll call it for demo. Now, the nice thing here is you can specify regex, right? So I could say anything that matches D star. I could use anything that has cube in there. I'll go ahead and just match demo very specifically. And then that adds it almost as a new source for a very specific namespace. And typically when you go deploy on Kubernetes, you deploy as what's called a daemon set. That means for every node of Kubernetes, there is now an instance that is being managed by Calyptia Core, and it is collecting all the logs that pertain to these namespaces or these inputs to route it to that particular backend. So in Red Panda, we're going to edit this here, and we're going to switch this from all inputs now to just the namespace matching demo. You go ahead and save that. And now we can go ahead and save and deploy. And what the fleet management for Kubernetes does is it goes and adjusts the whole entire daemon set for us. It knows the matching parameters, it knows the regex, it knows where to send it. And if I come back into my Red Panda console and we start doing some refreshing here, we should start to see some of those nginx logs. In fact, let's maybe do a quick search there. Maybe this is it. Let's see. Different pod name, but you can see there's also a lot of enrichment that's happening. So effectively what we also do with the Kubernetes fleet management is there's a lot of metadata information that is important, right? If we think of a typical log in a containerized environment, this message is just not too informative by itself. It doesn't include what pod, what node, where did this occur, how did this occur. So having the particular ability to go and enrich with all of this information makes it much, much easier to start debugging a particular, my app, which has this pod ID, this pod name in this namespace started malfunctioning. You can even see it gives you some of the host and container information as well. So a lot of that available. Let's do a quick refresh, see if maybe that now it's available here. Okay, let's see. Yeah, so it's collecting some information here on health checks. Let's see if nginx now lights up. Still nothing there. Let's go look at what those logs looked like. So epol, maybe something like that shows up. No luck there either. I haven't used the search here, as you can probably tell. So maybe let's just go down here, see if we can find any particular log that might match that specific. Now, the nice thing is if you put this in an index store or something like a Splunk or Elasticsearch, you'd be able to say, hey, give me anything that contains this pod name. In this one, we just chose something very quick to stream the data from like a standard out perspective. So which is why it's collecting all this information. Okay, so we'll go ahead and move on to the second part of Kubernetes fleet management. Right, is if we want to go add specific processing, if we want to add more sources. So say, for example, security, and go run something like that, connected up to a different endpoint. We have the ability to do so here. So yeah, this is what Kubernetes fleet management looks like. And again, we're orchestrating that daemon set that exists on the entire cluster, the entire system. And of course, you might tell, hey, this is a preview environment because what we're launching, which is fun to talk about here, is that new Red Panda plugin for Red Panda Cloud. Excellent. So let me switch back into our slides and let's talk a little more deeply about Edge, Edge and VM processing. So when we think of fleet management, the Kubernetes certainly can come up to mind, but one of the more common things is, hey, I've got laptops, I've got servers. How do I go about making sure that they're all running the configuration that is required here? And so if we go into Calyptia Core, let's go back over here, and we'll go into fleets. You'll see that we have one fleet here that's called Ubuntu, and it has one managed agent, then one of those that is healthy. What we're going to go do is create a brand new fleet. We're going to create some configuration here that's very specific for the purposes of this demo, and then we'll onboard this agent into that fleet. So with that, we're going to create a new fleet here, and a fleet, again, you can call it whatever you'd like. We'll call it Ubuntu webinar. And then what it gives you is, for those who are familiar with FluentBit, a raw configuration of that particular config. So in this case, it's running an input that has a dummy message that gets printed once per second, and it's just outputting that into standard out. Something very simple and easy to see. So we'll do something simple here too. We'll just change the message. And then from here, could validate the config, but we'll save and deploy. And we'll refresh the screen here. So we'll see the new Ubuntu fleet, Ubuntu webinar fleet. And now what we'll do is we're going to click this attach agent. And with attach agent, you'll see it populates configuration that we're going to go hook up the specific agent to. So I'm going to switch over to another EC2. Yes, this one. And it's a Ubuntu server. And on this box, I actually just have FluentBit running, or FluentBit that's available if we want to just test out, hey, is this FluentBit? Yes, it's 2.2, which was released last week at KubeCon. And so it's a very simple FluentBit that we have. Now what I'm going to do is create a new config. We'll call it fleet. Call it fleet config 2. And I'm going to copy and paste the configuration that I had within that console. And now if I start FluentBit with that configuration, what's going to happen is a couple of really fun things. The first is it's going to start and it's going to go register itself with the particular Calyptia service and go say, hey, what is my fleet? What's my configuration look like? Now, once that configuration is loaded, it will pull down the configuration and then it will do a hot reload. A hot reload means that the configuration, or sorry, the process doesn't restart. So the process just gets a, hey, we need to update ourselves. And the process then doesn't stop, doesn't terminate. It just says, let me update my configuration. And here's the new configuration that I want to run, right? This hello webinar configuration. So if I go back into that fleet, what we're going to do now is edit it. And if we edit this fleet, what we're going to say instead of hello webinar, let's go say, hello, this is an update for the configuration. And we're going to go and save and deploy. Now, automatically what you'll see is it says, oh, there's a brand new configuration. And it gives you a file path. So if you want to follow along or look at what the different configurations are, you'll be able to do that. And now the configuration is updated. So it's pulled down that new configuration, it's hot reloaded itself, and now it's running that, hello, this is an update for the configuration. I didn't touch anything, right? I just updated it in the Calyptia core side, and within the virtual machine, all of that has automatically taken place. So that's a great way for us to make changes live, without having to go into the box, modify the box. And there's a particular set of feature and functionality that I think is worth calling out during this flight. The first is syntax mistakes. So if we have a syntax mistake in the configuration, we don't want to push down that configuration, right? If it's invalid, why go and mess with the fleet? So the purpose of the fleet and showing some of those things, let's go back here. Let's go and even try to give a bad config, right? Something like blah, 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 something like that. And what's gonna, oh, let's do this. I think because I gave it spaces, it thinks it's a real thing. Let's go do something like this, save and deploy. It's going to say, hey, updating failed. So as soon as I go and try to put something that's crazy and just full of mistakes, it's going to go say, hey, I can't actually update this config because that's not valid. Now, the second thing, which is a great lead into, hey, why did it actually save the first time? I put spaces, so it does look like a legit configuration to FluentBit. You can have things like, for example, a rule that has, or let's say a header for something like HTTP. You can have authorization, bearer token, and something like this, and that's a fully valid config. So the spaces here from a syntax side don't necessarily get flagged because we don't actually know if something like that is valid or invalid. And that gets us to the next feature that we have. So within the open source side, we pull down everything, but within the Calyptia core agent, what we'll do is we'll actually roll back if one of those settings or specific values is incorrect. So you have, as you saw within the configuration, let's go back over here, is it's going to go and pull down all of the specific configurations. And as it pulls down those configurations, it goes and says, hey, I'm going to go store that configuration over here in INI format. That's the configuration that Fluent has. And so as it pulls it down, let's see, this is, I think when I gave it that kind of craziness, right? That property that doesn't exist. And what you'll see here, look at this, unknown configuration property, blah, 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 blah. This is not allowed. You're giving something that doesn't work. So while it passes the syntax check in the console, doesn't pass the actual reloading capabilities here within the agent. It says this is not something that should exist. We're going to not reload based off that. We're going to continue using the configuration that works. And the nice part about that is within the fleet management side, it will go and show you something that is healthy versus in progress. So let's go back to our fleets here. Yes. So here you'll see, look, I have a agent now that needs attention. Something happened. It doesn't have maybe the latest configuration. It's running on something that it had to roll back to. And that's really helpful within fleet management because we don't want to give a configuration that's going to cause issues or cause problems. We want you to continue running with that golden configuration. Okay. So let's go ahead and pause there. Any questions about fleet management or some of the benefits that come with running fleet management that I can go ahead and share?
There's a one in the chat, Anurag, of what platforms and operating systems are supported with fleet management. Are there any limitations there?
Yeah, that's good to ask. Really three main ones. So we support Mac on Intel, Mac on M1. We support Windows, both ARM and x86. And then we support a multitude of Linux platforms as well. We've worked within the fleet management UI as well to showcase a few of the more popular ones. So Red Hat, Linux, Windows, Mac, Intel. So you kind of get this nice generic script that will go run and pull some of the latest instructions for that particular agent.
Great. It looks like we got another one. How long does it take for a configuration to take hold?
Ah, yeah. So you can see that most of these were taking place within 10 to 15 seconds. The nice thing is, oh, the agents are checking in with the main service every 30 seconds. So they're sending metric data about how they're operating, what data is being collected, how often, what the throughput looks like, both input, output, if there's errors, if there's filters. And then from that perspective, it is something that can get updated very, very frequently. So you could give it maybe a lag time of 30 seconds, maybe in fortuitous time, it's about 10 seconds. And that applies to the daemon set as well. So within the Kubernetes fleet management side, right, when we went and modified the particular daemon set, we added the particular backend. That was something that happened fairly quickly. And yeah, this is the reason this doesn't show up is because it's not the new Red Panda, doesn't include the new Red Panda plugin, which is coming out here shortly.
Everyone's getting a first look today. There's one more question, and it's, are there limitations with what information can be used for a fleet?
Yeah, you can do metric collection, you can do log collection, you can modify that log collection. You can even put processing rules in the middle of that fleet management. So say, for example, you want to redact something, you want to add the host name, you have the capability to do that all within Fleet fairly quickly. So the there are specific ways to add third-party files. So if you do have a giant Lua script or giant Lua processing rules, some certs, and you want that to be distributed via Fleet, we can do that. It uses the CLI today. Otherwise, yeah, with things like parsers and stream processing rules, you can leverage the file side as well. Yeah, a lot of new stuff coming to Fleet here over the course of the remainder of the year. So things like, say, for example, uh, Canary deployments, making sure you can test out on one. Right, for us, right, we updated the entire fleet and it started to roll back. Instead of doing that, testing even just one single agent, more metric views around agent performance and trends, and of course, and you can see the UI right now is very configuration based, but within the way that we have the pipeline builder in Calyptia Core itself, if I just go and show that real quick, the idea is to mimic a lot of the nice aspects of a data pipeline. Say something syslog to Kafka, where I might take syslog here and maybe Kafka there. So to mimic something like this for fleet management as well.